what I want you to think about when you're watching this video is that you already know a lot of these things. We're just going to introduce a new way of framing the conversation around x and y, around independent and dependent variables. So we know that x we have seen as independent, or the input. Oftentimes it is the time that we've been seeing in a lot of these scenarios. We also have then the y is our output, and maybe that's temperature, maybe that's money, maybe that's cupcakes, all sorts of different things that are based off of the time and the rate of change that's been going on, or our slope. We can also, though, talk about it in a different way, which is really pretty neat, is that if we still think about this as our x, we can think about our y values as being a function of x. So that means it's going to be whatever the output is based upon what we put in. So for example, like if I have y equals 2x plus 4, that if I put in an x of 3, I get a y of 10. If I put in an x of negative 4, I get a y of negative 4. So depending upon what I put in, I get something else that comes out here. So these values are a function of what these values are. The x values are then creating the y. So there's another way we can talk about the output, or the y values, or the dependent value, and that's calling it the f of x, because it is a function of x. And remember, mathematicians are very efficient and want to be able to use terms where it's going to take really less time to write things out. So you can use the function of x, and you're going to see this on the next couple slides. But in addition to that, they could also say, as you could say, is the g of x, and that's the same exact thing. It just looks different. So that's still saying the function as a function of x. The h of x as a function of x. So whatever my x value goes in, I get a different thing for my output. So let's look and see what this actually means for us. Here is an example where the f of x, which we would have before this called y, totally fine, equals 2x plus 9. So now I'm going to say if x equals 5, what do I get? Then all I do is wherever I see an x in my equation, I plug in this value. So the f of x, or the f of 5, because I don't want to know for all x's now, I want to know specifically when x is 5, what's my output? So this is saying when 5 is plugged in, I get 2 times 5 plus 9, or 19. So the f of 5 equals 19. I could also, well, just so you can see a different one, something that looks a little bit different, is I could say, what is the f of negative 7? So now I'm saying when, this time instead of x being 5 as in the first example, x is negative 7. So I just say that the f of negative 7 is equal to 2 times negative 7 plus 9. Negative 14 plus 9 is negative 5. So that the f of negative 7 equals negative 5. And before we would have said when x was negative 7, that y would have been negative 5. It's the same thing. It's just a different language to describe the same relationships. Let's try a couple other ones. Here, let's do a couple on this slide. Let's find the g of 2 and the g of, oh, it doesn't matter, 100. So why don't you pause the video for a second, do these two problems, and then check them in a moment. Okay, so let's see what you have compared to what I have. So in this one here, I'm going to say that now I'm taking 1/2, that 2 is taking the place of the x plus 11, so I got 1 plus 11, so that the g of 2 is equal to 12. Let's take the second one here that you tried. So the g of 100, 1/2 times 100 plus 11, so that's 50 plus 11, so that is 61. So that now the g of 100 equals 61. So when we have an input of 100, we get an output of 61. But you can also treat this just like we know that if we wanted to find out, if we knew the y value rather, we could figure out the x value. So like if I knew how many dollars, I could figure out what time it was, or if I knew how many cupcakes, I could figure out how many minutes it or what minute it had occurred. So let's say here that I know that the h of x equals 22. So what I could do is I could, instead of saying here h of x, I'm just going to say 22 equals negative 3x plus 8. And then you would just do what you would normally do for a single step equation to solve it. Subtract 8 from both sides. 14 equals negative 3x. Divide by negative 3. So the x value, when you had an h of x that was 22, your x value is negative 14 over 3. The thing that I really like about function notation are nested functions, nested function notation. So if I have here, for example, I could say to you, I could give you this function here and this function here. But what I could also say is I could say the h of g of x. And we're going to use order of operations just like we do for everything, is that we would take care of this inner parentheses first and then take care of this outer one. So let's try an example together. Or I'll do this one for you, and then I'm going to put one on the other screen that I'd like you to try. So if I say, for example, the h of g of 2, we're first going to take care of this g of 2. So that means I'm going to plug in the 2 into this equation because this was the g of x. So this part here becomes 2 minus 4, or negative 2. So no longer do I have this here. Now I have the h of negative 2 because the g of 2, when we figured it out, was negative 2. So now we're going to say the h of negative 2. We're going to plug that into this first equation because it's with the h. So we have negative 4 plus 7, which is equal to 3. So that's our answer for, sorry, I shouldn't have crossed out, the h of g of 2 is equal to 3. On the next slide, I'm going to change the order of it and see if it makes a difference. So unlike the last slide, I'm going to now change the order of it. So now it's the h of 2 is on the inside and the g is on the outside. So we're going to take the same process that we did on the last one. We're going to start with the inside and plug it in. So I'm going to plug this into this first equation because it's the h of part. So I'm going to plug the 2 in. So I know this will be 2 times 2 plus 7, which is equal to 11. That takes care of the inside part. So this whole value here now has become 11. What I can do now is I now know that the g of 11, I take this value here and I'm going to plug it into this equation because it is with the g. So that would be 11 minus 4, which is equal to 7. So what I don't know, I think this stuff is really so awesome, I think, because the g of h of 2 being 7 is different than the h of g of 2. So order of operations does matter, which you know, but now with this new function notation you can see it a little bit differently. All right, thank you for watching this. I hope you have a super weekend, and I'll see you Monday.